Hi, I'm an old guy and I do maths, and the paper in front of you looks a little different today. It's an information sheet that I've made up for a pupil um, in order to introduce him to how sines work. So we're into trigonometry, and I do this from time to time. If you've been watching the channel, you'll have seen a similar one on tangents. So let's get into this and just talk through how these things work. Now, the idea is that all the information that you need to find an angle or a length using a calculator, and this is the calculator that I use. It's a Texas Instruments machine, all of about $30 at the supermarket, but it will do the job. So, the sine ratio is opposite divided by hypotenuse, sometimes written as opposite over hypotenuse. In the case of the person that I'm making this for, he likes to see it written this way, so that's the way it gets done. Okay, so this assumes that the person is familiar with how you get opposite and hypotenuse. So just to go over this quickly, the opposite side is the side that does not touch the angle in any way. It is over here. This is the angle we're interested in, or the angle we're going to use. The hypotenuse is the sloping side, and we're dealing with right-angled triangles. When the angle moves within the triangle from, say, here to here, which is its only option, then this side becomes the opposite. It is not touching that angle. The hypotenuse remains the same. Okay, right. So the idea of this is that using this sheet, someone should be able to find an angle or a length given the relevant information. So there are a couple of ways in which you might be presented with the information. So length 1, we have the length of the opposite side but not the length of the hypotenuse. And over here with length 2 we have no information on this, but we know the length of the hypotenuse. And the calculations are very slightly different. So we'll go through this one first. So the sine of 40 degrees is equal to 3 opposite divided by hypotenuse x. Now, in order to key this into your calculator for a successful result, what you need to do is you need to divide the sine of divide 3 by the sine of 40. That should be 40 degrees. Divide the 3 by the sine of 40 degrees. Push equals and you will get x. Let me show you. So we switch this on. We don't need second function or anything. It is 3 divided by the sine of 40. I like to close the bracket. Hopefully you can see that. The light's not getting in the way. Push enter and you can see the result. 4.67 I've rounded this to. So whatever units these are, this is 4.67 of them. This could be feet, inches, kilometers, meters, whatever. Okay, so that's the first way in which this gets done. So if the setup looks like this, if the hypotenuse is unknown, this is the way that you key things in. Now, if the hypotenuse is known but the opposite side isn't, the sine of 60 in this case is equal to opposite divided by hypotenuse, x divided by 6. Now, when you key this in, these are the keying instructions. So, 6 times sine 60 degrees, and push go, and you get 5.19, which I have rounded to 5.20. Now, those are the two circumstances in which you use a sine on a right-angled triangle to find a length. You're either looking for a hypotenuse or an opposite side. Now, we come to the business of finding angles. And this is the second part of this. And let's just look at the possible scenarios. We have opposite and hypotenuse in each of these, but we're looking for different angles, and as a result of looking for this angle and this angle, you will note that the opposite side moves. That's the point here. The opposite side moves from here when we put our angle there, it moves from here to here. Otherwise, the calculation is very, very straightforward. So, the sine of whatever this is equal to 4 divided by 5. 4 over 5. Opposite over hypotenuse. Now, to make this happen, what you need to do is you need to use the second function on a TI calculator. So second function, sine, and what will come up is sine -1, and a bracket will open. And you divide 4 by 5, so sine -1, 4 divided by 5. 4 divided by 5, close the bracket, and I'm going to push go, and I get 53.13 degrees. So our angle is 53.13 degrees, that angle there. Now, coming over to this one, all that's changed is the location of the angle and therefore the location of the opposite side. We actually do exactly the same thing, but with different numbers. So, second function, sine, that gives us sine -1. 3 divided by 5, close the bracket, push go. 36.87, shall we say. Hope you can see that. There we are. Which I've rounded that to 36.87. Now, as it turns out, these are 3, 4, 5 triangles. And so this side is actually 3 and this side is 4. So they are the same triangle. And what I've done is I've found this angle. And just to check that I've got this right, reveals that if I add this and this, I get 90 degrees. And that angle and that angle in a right angle triangle should add up to 90 degrees. So there we are. All present and correct. Now, this is not, as you will have noticed, the normal way in which I present my videos, but I find that it's useful to go through these worksheets from time to time. And the great thing about them is that I can laminate them up. You can see that that's laminated, hopefully, and it's two-sided, and I've got all the information that my pupil, who's in a sort of a lower class at a high school, by which I mean a junior class at a high school, that's all the information that they need. And they've got that as a quick reference. That's the idea of this. So I hope those of you who are getting into trigonometry find this useful, and you might want to copy this. I'm perfectly happy with that. Okay, well, thank you very much for watching. I do hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.